episode of FUM0120 machining we are going to do the first part for machining for fun. The end product, the target here is to do something that is totally useless, and it is probably also very hard to do, for me at least. But actually I like challenges. So let's see what I'm about to do. Oh yeah, this is going to be more than one part really. I cannot fit all this in one video. So therefore there will be at least, I believe, 5 episodes of this. I try to make them a little bit shorter. Okay, but now let's see what I'm trying to do here. So here is my chicken sketch of this what we are going to do today. First of all, the name of this project is Stirshurst engine. So it's number 1. And it's going to be quadratic, rectangular piece of steel, which is about 50 millimeters side, 53 to be exact, and then it will have a deep hole, which is a blind hole actually, 40 millimeters in diameter. Yeah, and then on the sides, these sides, we are going to have identical holes with some bolting features, etc. Okay. Well, the first thing to do here is to cut a suitable piece from material which I already have done. This is done. The next thing is to mill it to exact dimensions, and because this is machining for fun, I will overdo this in a way. So that it will be, it doesn't need to be very accurate. 1 millimeter accuracy is way enough here, but I will do it as accurate as I can, and I will be using for it to be rectangular. I will be using this one. That's probably good enough for this one. Okay, next step will be to go to when I have done these sides, then the top and bottom sides are still unmachined. So I will put this piece into, this material is somewhat straight anyway. So I will put it into my lathe, dial it in. It will be really interesting to do. And well, I know already how to do this, but let's go there when we do it. So we put it into a lathe in a 4-jaw chuck, and then we face first this as underside here. We face this side, and then we make the hole there, the deep hole, which you can see also here, and then we turn it around and face the back side. Actually, this dimension is not critical, but it's very important surface, because it's totally visible. So therefore it needs to be best possible. So well, that's what we are going to do today. Oh yeah, and these holes I will do in milling machine, because they need to be somewhat accurate places, as well as these. I will do the boring job in milling machine this time. Oh yeah. Okay, let's go on with the milling now. that we have done the milling, and I have checked this part with a micrometer, and it is there is one edge that is minus 200ths of a millimeter, and the overall its overall accuracy is I would say well, 400ths of a millimeter overall accuracy, and well, the surface finish is excellent. So you probably might have questioned why I did use coolant while doing these surfaces with the cell mill. This shouldn't need any of those. Yeah, I tried it once, and it makes better surface finish when you use the coolant for some reason, and usually that also means if it's doing a better surface finish, it is also more accurate. That's my opinion about this, but it's just my opinion. Okay, next thing to do is to find a center here for this 42 millimeter hole. And this doesn't need to be exactly on the center, so well, I will put it as exactly as I can. Well, first we need to find a decent center on this one. Well, I could draw just lines from corner to corner, and there you would have the center in the middle. Okay, that's one. Another method is to use this tool, not with this, but with this. This tool can be used to find centers in round objects, but it also can be used if you have really made this somewhat perpendicular. You just, well, it will be faced anyway, so I will do it like that. From every oh yeah, okay, I believe we are there. So now we have a lot of lines there which are not intersecting in one point, but the actual center point will be in the center of there, of where they crisscross. I will now take a photo before I make the center punch here. So, as you now can see in the photo, I will place it somewhere here. Here. So, you can see that there are like multiple lines crisscrossing here in the center. So, what I will do now is to find where is this center of gravity. Actually, there is a rectangle there in the middle. I will put my punch here somewhere quite near, and then a very light tap. See that it went in correct place. With it a little bit more, yeah, and then a decent click. There you are. Yes. There we have our center. Okay, then let's go to the lathe. Now, setting up this piece, there is our center, there is nothing this side, so in my 4-jaw chuck. And this is, I already adjusted the jaws in the correct solar system, so that we don't have that much to do when doing this. So, as you remember, these jaws are actually very sharp there. So I will put aluminium spacers here in between. like that. Next one. These help to keep the surfaces looking nice. Otherwise there would be really bad dents in that surface. But these should now prevent that from happening. So, and as you probably can see, I have reversed the jaws so they don't interfere with our cross light. So now, we will be needing this one to hammer it in at some time, but now I can visually see already that it's not in the middle. So this one, and if I look into the jaws, I can see that as well. So, and these tend to drop when you, these pieces, so hopefully they don't. Hopefully they don't drop like that. And where is it now? Can I see it? Oh, yes, I can see it. So it's a good idea to keep your chip pan semi-clean. So, baby steps, I believe. That's okay. Tighten this, loosen this a little bit more, keep it in place manually. Okay, looks a lot better now. And this one also has some these tend to drop, as I said. There you are. Now, when looking to jaws, these are okay. Well, it's way better. Now we take this thing, but let's first hammer it in a little bit at least. Let's see how this was this. Oh, where is our? There is the center. Let's put this a little bit farther away, and I don't put a lot of pressure there. Well, it's quite in the center. Let's see now. This was in wrong orientation. Okay, we get quite near there. Hopefully it doesn't, you know. Oh. This, then go back to 0. Well, it's there. And now what we need to do is to hammer it in a little bit. This will change the centering for sure. Okay, now it sounds good. Okay, there you go. Well, it's 200ths of a millimeter, and this being high. Okay. Well, I believe it is now there. Well, here I would like to demonstrate the microscope for you. This is really nice. Here I'm centering the drill, because this tailstock drill chuck needs centering. So let's see. This is now a picture of this this thing, and as you can see now, you can clearly see the 4 lines and the center there in between. So now I move this. This is the view is from the up, and let's put it very near. So I'll take the backslash away first, and then I move it to the middle. I think that's straight from the up. Okay, and from the side, if you look this way, this is from the side. It's also quite center. Is it? It's a little bit under, isn't it? Oh, let's see. Oh, I have to put this in correct orientation. Oh, this is a little bit. Yeah. Not just a little bit, it's quite a lot actually. This is something like 1/10 of a millimeter. Okay, I need to adjust that. Let's see now. Let's first loosen this. And then take it up just a hair. Tighten it again. Still, I think a hair under. Now, this is really fine thread, really. Yeah. Adjusting. Aha, it bites. It droops. Yeah. Okay. Now I tightened it, and now I believe it's in the center. Yeah, now it is. Now I tighten my adjustment nuts here. Well, I didn't do this earlier. And then we look into these. Let's see again. There you are. Okay, now what I will do here now is first I will center drill it, just to make a little center there. After that I will put this is 7mm drill, to the correct depth. This one, this is 11mm drill, to the correct depth. And then this one, well, I cannot use the cross slider, the stop thing, carriage stop, so I need to feel when it's at the end. Okay, and when all that is done, then I will bore it to the size with this. It's a Cermet insert, and I will then bore it to the size. Okay, now that the lathe work is finalized, so, well, there is a scratch. I don't know where did I get that one from there. Okay, anyway, first of all, these back and front side are parallel, within 200ths of a millimeter measured from each four corners. And of the perpendicularity I don't know nothing about. They might or might not be. Well, yeah. They are as perpendicular as my started measuring tool. The diameter here inside, I got it surprisingly accurate. It's only 1/100th of a millimeter undersize. I have measured it 5 times and it's really on the back and front side everywhere the same diameter. And the finish is, as you probably can see, it's well, I wouldn't desire a better finish. Only lapping, I believe, can make it better, and you, of course, you cannot feel anything. And I used this insert, this one, yeah, this insert to achieve the surface finish here, which you didn't see probably. And well, the back side of this hole, which is a blind hole actually, that was difficult, surprisingly difficult to do, especially when my tool was rubbing from this end. But when I ground this away, so after that, it, as you can see, it made all the difference there inside. But the damage was already done there, and I didn't want to take away the extra. So yeah, the depth is the target 25 millimeters quite exactly. Yeah, good. So we have 3 millimeters here in the back, and then I turned it around in the lathe, and after that I faced this one. And you probably noticed that I forgot to say that I have to, and I not only forgot to say, I also forgot to do it, to face this before starting any boring tasks on this side. So then I faced it, and it became quite good. Okay, the next thing here will be the 4, wait a minute. The next thing here will be the 4 M6 threads. So we need to drill 4 holes here and then thread them, M6. And this will happen in the milling machine. Well, now attaching this part into the milling table. Well, it's it's quite an easy task to do. So first I take this, that, and one nut. Oh yeah, don't lose it there. One more reason to keep your slots clean. So let's see now. Put it here, this one, and then we have here. Well, now it's not tight. So this one I use for coarse setting. Let's move the table a little bit this way, so I have room for this one, this side. Well, it looks like straight. Yeah. No. Now it is more like straight. But the final everything is alright, yes. So now I have this test indicator this side. I will now start this camera so you can, I will put the picture in the corner so you can see. Let's hope the picture is okay. So just by the starret, and so it's 3/100 of a millimeter difference. Yeah, 3/100 of a millimeter, which way is high. That way is high. So this corner is very little higher. Can I knock it with this one? Yes, I believe I can. There you are. Hopefully it doesn't move when I... Oh, it did move. No, it was just the just my measuring equipment that moved. Okay, good. So I can tighten this one too. Looks really good. So that's it. Next step is to find out the origin. And the coordinate system on this milling machine is such that now let's lose this one. So it's such that when you so this way is 0 and these coordinates raise when you move the table that way. The same here, this way is 0 and when you move that way the coordinates increase. So, well, this is, again, I will show you this. That's a pin, like that. It has a very, very sharp edge and another very, very sharp edge. I have a few dozen of these and they are quite accurate. And the diameter is 5 millimeters, as is the drill we are going to use here today. So, let's tighten it there. Tighten. So this coordinate becomes the origin. And all the coordinates I have in my plan will be, this will be the reference corner here. So what I will do, I will now point this point into that very corner. There you are. I believe it's quite exactly there. So at the moment I lock it up so it doesn't move. So what I will do now. So first of all I will lock this wheel here. The table is locked and now I will adjust this so that when I would be moving in that direction, so the backslash is eliminated to that direction. So now it's 0 here. Okay? And then furthermore, I will 0 this one. This is the coarse, so it's now in 0, my analog readout. So now this accuracy is 1 millimeter and this one is 2/100 of a millimeter. So with these two I can place this quite exactly where I want to. Yeah, okay. X done. Then, if this is X, so then Y. So, let's locate and drill the first hole. So, the X-axis is, according to my drawing, 7.5 millimeters this way from the origo. So now it's a 0 here, Well, oh, I need this nevertheless. So that should be 7. Yeah, this is quite a match. And then 0.5. There you are. Lock the table. And then this one as well. 7.5 millimeters that way. This is on 0 now. And that should be 7. Yeah, and 0.5. There you are. And lock the X. Okay, the position is now correct. And then we set the speed of the drill. We are using high gear. I have indicated 15 millimeters deep hole. So let's first touch. Okay. Now I zero this dial here. That. And then 15 millimeters. So 15 millimeters. Wait, please. 15 millimeters equals 10 turns in this wheel. So I have to calculate this 10 turns, and I will calculate this in Finnish. So please forgive me that. So, and this is a split point drill, which doesn't wander around when you do it like this. So what we need is auto feed, and this one will be quite slow. And well, it's there, everything is there, a little bit. I will put this oil on the cutting oil on the shaft of the drill, so it will slowly go down into there. So 10 turns. Hole done. That's the next hole, and then I will do the next hole, and I will come back when I start threading those. Let's have some fun with tapping. So this is an M6 spiral flute tap. The reason why I'm using spiral flute is that it is pulling the chips out from hole. And now I will. This is a plug tab, so it doesn't make the threads all the way to the bottom. Unfortunately, I don't own bottoming tab, so this will have to do. So this is pretty simple operation. Now it's placed there. I have my tab follower here, and then I just make the thread. Hopefully not breaking the tab into there. That would be not very nice. Yeah. Okay, and here I'm demonstrating you how the spiral flute tab will actually push the chips out from the hole. So actually there is no need to break the chips. Okay, let's go. Watch carefully what happens there. The chips are coming out, as you can see, really nicely. So normally those chips would be, if you would have a straight tab, those would accumulate in the flutes, and that would be really bad. That is one reason why you need to break the chips with that kind of, and we are done. And yes, it produces this type of chips which are, oh well. There you are. Okay, this is our menu today. So, first of all, what we are making here. Oh yeah. So what we are making here is these holes here. The big one and then the small threaded holes there around. Okay. First of all, I have now dialed in the vise into the mill, and then after that I put the piece into the vise and then use this parallel to align it to the side of the vise. I did this because I need to do two identical sides. So now it's just turn it 90 degrees and do the other one. Then what I have done is I have set up the origo, so the reference point. That's now done. Now the next thing to do is to poke in the very center a 5mm hole. Yeah. And when the 5mm hole is done, we will enlarge it to 12mm. And when that is done, I will use this carbide end mill to enlarge it wider to 16mm. And when the 16mm hole is there, just a light chamfer for that hole. Okay, that's the big hole. And when the big hole is done, then we will do 4 couples of 4mm holes around it. And this one is for the M5 thread. Actually the drill size for M5 would be 4.2mm, but I think I will survive with this one. Okay, and when all the 4 holes are done, then I will do a light chamfer for those. that is done. Then we will, with the rest, I will do the M5 threads, and again we have a spiral flute tap, and those will be blind holes 7 mm deep. Okay, this was the first part of this machining for fun project. Stirshurst engine. This is the part that I have now made. Let's see a little bit closer. I made one. This is a mistake, the backside there. Okay, that one I made, and furthermore, that one. That's actually, that might be bad. No, it's not. I know already. So why this kind of thing? Yeah, it should be, there will be compressed air inside, actually. So there is one feature missing from this one, and I didn't make it because I'm not sure how to make it at the moment, and it can be added later. So so far this part is ready. Quite good finish, I would say. It might benefit. No, it's okay as it is. Maybe beautifying the visible surfaces, but this is really like looks like somebody had machined it. Okay, in the next episode of FUM0120 machining, we will be doing the second part of this machining for fun. Till then, bye!